Hi, I am Varun Joshi, and welcome to day 5 of our Jenkins Basics to Production course. Today, we will make Jenkins actually ship an application. We will set up Docker outside of Docker, which is also called DOOD. So, our Jenkins container can use the host's Docker engine. We will add credentials safely and then build, push, and deploy a tiny Flask app end to end. So let's get started. Now, on the left, you see what we have, and on the right, what we want. Before explaining this diagram, I want you to understand that we have a Jenkins container. That Jenkins container is running commands for us, and we have seen that we were able to run commands specific to Git, we were able to run commands specific to Maven, and so on. So any commands that we were able to run, that binary was available to our Jenkins container, or we configured that binary using tools section in manage Jenkins. So essentially what I'm trying to convey is whatever tools that we are using with Jenkins, those tools are somewhere available to our Jenkins container. So if in this lecture we want to build images and we want to push those images to a container registry, then we must have an OCI compliant tool in our Jenkins container so that we can build container images and then push them onto container registries. For us, the tool of choice here is Docker. You could use any other tool that can be used to create OCI compliant container images like Builda, Canico, and so on. But in this lecture, what we will do is we will configure Docker in our Jenkins so that we can use Docker to create OCI compliant container images. Let's see how we are going to achieve that. So on the left, you see what we have. We have a Docker host, and Docker host is essentially my laptop. And in that laptop, I have installed Docker desktop, which is why I am able to run containers. And you see, this is a Jenkins container here, and I am able to access Jenkins container from any browser in my laptop as soon as I access localhost on port 8080. This is understood because I am forwarding anything that is coming on my localhost's port 8080 to my Jenkins container, and that's how Jenkins is accessible. And whenever I am running any Docker specific commands, then Docker CLI in my laptop is interacting with the Docker daemon, and that is how I am able to run any Docker specific command. So if I go to my terminal here and if I run Docker PS, then I see that there is a single Jenkins container that is running in my Docker host. And I know this because I can run Docker specific commands. And why I can run this? Because I have Docker CLI and Docker daemon configured in my Docker host or in my laptop because I installed Docker desktop. So the crux is Docker CLI interacts with Docker daemon to run Docker specific commands. Then what is var run docker.sock, Varun, and why have you mentioned it here? So if I talk about a Linux machine, there could be multiple processes in that machine. And if one process wants to speak to another process, they can use something called a socket file. Now, socket file, when being used, they bypass the TCP IP part. So essentially what you do is you communicate between these two processes using a socket file. An extension to these socket file is .sock. So essentially when Docker CLI is interacting with Docker daemon, and they can be thought of as two processes, and these two processes are part of Docker desktop at a very high level. And when these two processes, Docker CLI wants to interact with Docker daemon, it is using this specific file. So this is the architecture we have. Now what we want to do is we want to install Docker in our Jenkins container so that we can run Docker specific commands. Now one way to do that is I install the entire thing into this Jenkins container. And entire thing is I install Docker CLI along with the Docker daemon. And once I do that, I can run Docker specific commands, and I can also run containers. But I want to take a different approach. Now, if I had installed both CLI and daemon into this Jenkins container, then that architecture is called DIND, Docker in Docker. So essentially, if I would have done that, then I could create containers within this container. That's pretty cool. But in this lecture, I do not want to do DIND. What I want to do is DOOD, and DOOD stands for Docker outside of Docker. Now what happens in this is you just install Docker CLI in the Jenkins container. Then Varun, if I am creating a container image and I do not have Docker daemon installed, then how would that work? This will work because what you do is you just install this Docker CLI and you instruct this Docker CLI to communicate with the Docker daemon that is installed onto the Docker host. So essentially what we are doing is whenever I do this, whenever I run this sort of architecture, then there are two Docker CLIs that can interact with my Docker daemon. The first one is the one that is installed in Docker host, which is hello, the obvious. And then second, we have this Docker CLI that we will install onto the Jenkins container. And if this Docker CLI runs Docker PS, it will see this output right now. And if this Docker CLI runs Docker PS, it will also see the same output. Why? Because they both are using the same Docker daemon. And Docker daemon, you will also hear people call it Docker D. So if they are using the same Docker daemon, then they will see the same output. So this is what we are going to do. But there is one more point that I want to cover. And that point is, for this Docker CLI to communicate with this Docker daemon, I must be sharing this file with my Jenkins container, because Docker CLI by default looks for this file when it wants to interact with the Docker daemon. If it doesn't find this file, this will not able to do that interaction. So what we want to do in this lecture first is we want to mount this file as a volume onto our Jenkins container, then install Docker CLI so that this Jenkins container can interact with the Docker daemon that is installed in our Docker host. So you now clearly understand what DOOD is and what DIND is. So DIND in summary is when this Jenkins container has both Docker CLI and Docker daemon, and DOOD is when you just have Docker CLI and this Docker daemon is shared between your Docker host and your Jenkins container. As simple as that. So with this understanding, what we have to now do is we have to delete the existing container we have, and we have to recreate this container by adding additional volume. So let's do this. So I'll go to my CLI. I will first docker stop Jenkins and then docker rm Jenkins. Now we will not have to do the installation, the whole thing again, because like I mentioned before, we have externalized Jenkins home, and Jenkins home is where everything Jenkins is available. So we will be using the same volume that we had before. So I'll just paste the command here, and everything that I'm doing today, or any lecture I have in this channel, everything is available in the GitHub notes so that you can follow step by step along with me. So here I'm saying docker run -d, run in the background, name of the container is Jenkins, restart is unless stopped. So if I restart my Docker, then you restart this container as well, because I only want you to not restart it if I have deliberately stopped this container. Then I'm saying -p port forwarding, anything that hits on port 8080, send it to 8080 on my container. This is for my agents, we are not using them. Here is the important piece. So this Jenkins home already has what we have configured thus far. We are just mounting this onto this path in our new container, and this is the interesting piece. This is the second named volume that we are mounting. Here we are saying var run docker.sock, find this and map this onto var run docker.sock, as simple as that. Here I'm defining the time zone and I want to use the Jenkins image, which is the latest. So I'll press enter and this will create the Jenkins container for me. So if I go to my browser and I access local host on port 8080, then I will see my Jenkins container up and running, and the previous jobs that were there in my Jenkins installation are still there because all of this is stored in Jenkins home and we used the same volume, the named volume that was used before. So I'll go to my terminal again and I want to show you something. So what we will now do is I will docker exec -it, and Jenkins is the container I want to exec into, and I want a bash here. So I am logged into my Jenkins container. So if I run ls-l var run docker.sock, I press enter, you see the ownership of this file is with root, but we are logged in with our Jenkins user. I want to mention one thing. While practicing for this lecture, I already added others as read write. So you see, this is your owner, then you have group, and then you have everyone else, that is others. So others also have read write. So for me this is okay, but if you are running this, you will have to run chmod 666 on this file, so that when Jenkins user tries to access this file, it can access it. So if I press enter, operation is not permitted. What I will do is I will exit from here and then I will do the same, but this time I will log in into my Jenkins container as user root. So I'll press enter then, and now I want to run this command again. So if I run this, it will not make any difference for my specific installation, but if I do ls-l and I type this path here, let me remove this. So what I will see is this has the others have read write, and you should also see this. So run this command in your installation as well. So once I have done this, I will again exit from this container, and now what I want to do is I want to install Docker CLI in my Jenkins container. So again, what I will do is I will again log in as root. I will do this and I will clear my screen so that we have more real estate, and then I will go to the GitHub repository of this course and I'll scroll down, install Docker CLI inside the Jenkins container. I will click on this, and then you see this is what you can use to install Docker CLI. So I will just use this one here, and I will go here and I'll paste this here. I'll press enter, and this will install Docker CLI for me. Now we can exit this. Remember, we have given our Jenkins user access to var run docker.sock file. So I'll exit it and then I will log in with a normal user, and that is what you should be doing when you do not need root user, when you do not need the highest privilege. then log in using a normal user. And this is not just applicable for Jenkins, but as a principle in the IT industry. Whenever you are using Linux boxes, log in with the user that has only the required privileges. So I'll go here. I'm logged in as Jenkins now. I'll clear my screen. And if I run Docker version now, voila, I see Docker version is 28.4.0 and this is the build. And why I can run this command? Because I installed Docker CLI, and that Docker CLI is interacting with the Docker daemon installed in my Docker host. So if I run this command in my terminal, docker -- version, then you will see the same output. You are seeing the same output because both of these are interacting with essentially the same Docker daemon, Docker D. So the build is also same, 465, and you see 465. So I hope this concept is understood. Now comes the interesting thing. If I run docker ps, I see the same Jenkins container, because like I told you, the Docker daemon is common. So now that we have this understanding, let's see what we have to demo in this lecture. So I will go back to my diagrams and I will scroll down, and this is what we are going to do. So let's see what is happening in this diagram. We have Jenkins at the very top. Jenkins is the orchestrator that will ensure all of these things are done seamlessly. All the steps are done one by one. And before I start with this demo, I want to tell you one thing. I did this demo 6-7 years back when I was learning these tools, and with advancements, few of the things have changed. But when I completed this project, when I completed this demo, I was so exuberant that wow, I created a container automatically. The code came from somewhere, the build happened somewhere, the deployment happened somewhere else. So this was a very cool feeling for me, and I hope once you do this demo, you will have the same feeling. So let's get started. So the first step is, what we are going to do is we'll be creating a private repository, and we'll be using GitHub for that. And you can use any Git host, but we'll be creating a private repository because that is what you will see in production. And if you have configured private repository, then you will have to configure credentials, because that is how Jenkins will access your repository. And what will we have in that repository? We will have our source code and we'll have our Docker file. Once that is done, we'll ask Jenkins to build container image for us using the command we know, docker build. And why will Jenkins be able to run this command? Because we have just configured Docker in our Jenkins container, Docker CLI to be specific. Then in the next step, we will push this image. Now understand, we will be pushing this image to Docker Hub. To push this image to Docker Hub, Jenkins must have the credentials for Docker Hub. Only then it will be able to push into the Docker Hub account named Cloud with Varjosh. So we will be configuring the credentials using the available Jenkins plugin. And why I say available, because while we were configuring Jenkins, when we were installing Jenkins, we selected an option which said install the recommended plugins, which is why most of the plugins that we'll be using in this lecture are already there. And then we will be finally, once the container image is pushed, we will be creating a Docker container using that image. So this is end to end, from creation, from code to deploy. So we are doing everything. We are checking out the source code, the CI part, we are building it, we are pushing it, and then finally we are deploying it. And then at the very last, we'll perform a quick smoke test. What is quick smoke test? Smoke test is just checking whether the application is able to perform the basic functionalities it is supposed to perform. For example, we will just check whether our application is accessible via the browser or not. So I hope you have an idea of what we are going to do. So let's get started. So I will go to my browser. I will go to dashboard of Jenkins. I will close this one and then I will come at the very last here, and then I will create a new item. And this time as well, we'll be creating a freestyle project, but do not worry, in the next lecture, we'll be converting whatever we are doing here into a pipeline, that is Jenkins file. So do not worry, that stage is about to come. We are moving step by step so that we can cover everything. So let's come here and let me name this job. So let's call this cloud with Varjosh, and then I will add DOOD, and then I will add Flask because it is a Flask application that we will be building. So I'll be showing you the code in a while. So for now, just select freestyle and we'll click OK. Now here I will select Git, but we do not have a repository yet. So let's create a repository. I'll go at the very top, and then from here I will choose cloud with Varjosh, and then here I will choose create a new repository here, and then new. And what do I want to call my repository? I will call it cloud with Varjosh hyphen private hyphen repo. I will not give any description. Let's keep it like that. This is not public, this is private. So ensure you change this cloud with Varjosh private repo. I will click on create repository. This will create the repository. I will add a few files into this repository. So what I can do is upload an existing file here. I will click on choose your files, and then I will go to Varun Joshi here, courses, Jenkins basics to production, day 5. Under the Python directory, I have 3 files here. I will just open them. Do not worry what is inside them. We'll see that in a little while. So all these 3 files are being uploaded. I will click on commit changes, and you see my private repository has 3 files. Now I have these files, but I want some means via which Jenkins can access my Git repository, my private Git repository. So I will go here, I will click on settings here, and I'll scroll down. I will go to developer settings, personal access token, PAT tokens classic. Let's use them. I already have one. This is the one that I'm using for this courses GitHub repository. So I'll create a new token, generate new token classic, and here I will type Jenkins GitHub integration so that I know what is this used for. I will give the repo level privileges, and let's keep the access for 7 days, and I will click on generate token. So here is the token that is generated. Ensure you keep this token somewhere safe. After this lecture, before uploading this video, I will delete this token. So it is fine that I'm sharing this right now. So I'll copy this, and then I will paste this token in my browser so that I can use it later. Then I will go here, and then I will type the repo URL first. So I'll go here, and then I will go to the repository that I just created, CWVJ private repo. I will go to code. I will copy this. I will go to my Jenkins now, and I will paste this URL here. And as soon as I do it, this will give me an error that you have to provide some credentials, and I have not created any credentials for it. So if I click on the drop down, I don't see any credentials. So I will click on add here and go to Jenkins. This is fine, global credentials, and then it is asking me what type of credentials do you want to create. Now for this one, I will just click on username and password for now. Username is not something we have right now. We do have, but we are using PAT, personal access tokens, to access our private repository. So we can provide any username. This will be used as a dummy. So for this, I will just write CWVJ GitHub so that I know that I created this username for GitHub. Then I will go to password, and in the password section is where I have to provide this token. So I will provide this token here, and then I have to give it some ID. So I will call it GitHub hyphen PAT. So keep this name meaningful because it is via ID that you will call your credentials. So give this an identifiable name. So I will click on add. Once I do that, I will see in the drop down there is cloud with varjosh hyphen GitHub. That was the username that I specified. Then you see the token here. If I click this, this should just work. You see that error, that red error is now vanished. So I will come down, and here we have the master branch, and in GitHub what you see, a main branch. So I'll just remove this and blank for any. We have only one branch, that is main, so this will be taking action onto that branch. I will scroll down, now here what I want to do is add build step, and add build step I will use the same execute shell. But before I do anything else, let's go to Visual Studio Code and see what are we going to configure. So I have three things in the Python directory. There is app.py, there is a Docker file, and then there is a requirements.txt. So first let's explore our code. Our code is written in Python, which is using the Flask framework, and this is the framework that you can use for web apps when it comes to Python. It is a very simple code which will just print the message, welcome to cloud with varjosh, tip is built with Flask, shipped by Jenkins, running in Docker, and then we are exposing our application on port 5000. So this is where I am defining that my application, my Python application, is going to listen on port 5000. And then let's see the requirements.txt. Now what happens is, when you are dealing with a production grade implementation, you mention all the packages that are required by your application in a different file that is called requirements.txt, so that all the packages can be found in one place, that okay, this application requires these all packages. Now our Python application only requires Flask, which is why you only see Flask here. So let's go to the Docker file and understand what we are doing here. We are saying from Python, this is the base image that we are using. Of course, it's a Python application, which is why we are using slim Python image. Then I'm saying work dir is /app. So essentially what we are saying is, whatever commands that I run next, you run them in this directory. It is defining the current working directory for this. In the next instruction, that is the copy instruction, we are copying the requirement.txt to work dir. So if I write this is the present working directory, and which is the present working directory, it is /app. In the next instruction, that is run, we know that run is used to install or run any commands that you want to run. So here we are using pip. What is pip? Pip is a package manager for Python. We are saying pip install no cache directory -r, and this is the requirement.txt, from where you can fetch the packages that I want you to install. Now I want you to know that whenever you are creating container images, your aim is to have everything in that container image that is required by your application and nothing else. So for example, when you use pip for installing something, you have the download cache and so on. So here what I'm saying is, discard the cache, only install this. So this will install Flask. Then I am using the copy instruction. Copy instruction is used to copy the code to the /app directory, and that is what app.py, and app.py has my code. And then I'm saying expose 5000. This is a documentary instruction which is saying the application that we are building listens on port 5000. And finally, I am running Python application. I'm saying Python run app.py, run the code that is in app.py, as simple as that. Then I also have a .docker ignore, and you can see what all things are here. So This is what my Git has. Now, I want you to clearly know that we discussed in the last lecture that if you go to var Jenkins home and if I do ls, then whatever jobs we are creating, those jobs will be stored here. And whenever you run that job, so the build happens in a scratch space, and that scratch space is workspace. So whenever I perform this git checkout here, so for example, I have written this here. So whenever I'm using this plugin, what this plugin will do is it will perform a git checkout. So it will clone whatever is there in my repository in the workspace. So essentially, if I cd into workspace, you will soon see when I run this, there will be a new workspace with the name, whatever is the name of this CWVJ DOOD Flask will be created for us. Now let's come to the meatier part, that is execute shell. So I will copy and paste commands and I will explain you step by step. I wanted this to be complete, which is why I'm not typing every command. That will make this lecture extremely long. So let's not do that. So I will copy the first command that I want to run and I will paste it here. Now read what we are doing. Docker login uses injected environment variable. Understand, like I told you before, we will be running docker specific command, we will be performing docker push, and for that to happen clearly, what we want to do is we want to perform a docker login. But Varun, what are these? You have not created any credentials for Docker Hub yet. So let's do that and then we'll come back to this step again. So I will scroll up here. I will say, yeah, environment. In the environment section, I will choose use secret text or files. I'll click on this and I'll click on add binding. And here I will be choosing username and password separated. Okay. So the username variable is, let's type Docker Hub user here, and then what is the password variable? Docker Hub. If you're not getting this, just hold on, we'll look into it. And password, and here it is saying which credentials you want to choose. Now this I am creating for Docker Hub, but remember, in the step here we created credentials for GitHub, we did not create credentials for Docker Hub. So let's do that. I'll click on this and open this in new tab. I'll go here, I will go to credentials, and here I will click on this, and then I will click on this, and here I will click on add credentials, and the username is, now here you will have to enter the username of your specific Docker Hub account. So my username in Docker Hub is cloud with Varjosh, which is why I am typing cloud with Varjosh. You will have to type your own. And I think I forgot to explain this scope. The scope global implies the jobs can also use these credentials. If you keep it to system, only your Jenkins controller, that is your control plane, and your nodes, that is your data plane, your agents can only use these credentials. But we want our jobs to use these credentials. Hence, I have selected global here, cloud with Varjosh, and then here I will add my password as well. I will type the password for my Docker Hub, and then ID, I will give it a ID that I want. Let's call this Docker Hub because this is what I will see in the GUI. So now cloud with Varjosh is the username. Here I have typed the password. I have the ID as Docker Hub. I will click on create now. So we have the credentials for both GitHub and Docker Hub. So let's go to our pipeline again, and then I will scroll down, and here you see specific credentials. I do not see that yet. So let me do one thing. I'll just copy this one so that I have to type less, and then I will close this. I will click on add username and password separated. So you can also have co-joined depending on your requirement, but I want to specify user and password separate, which is why I'm choosing separated. So here the username variable is Docker Hub user, and the password is Docker Hub pwd. So what we are saying is, when we are running this pipeline, we will call these using this variable. Now I will tell you why this is helpful in a little while. And then here, which password do I have to use? This is for GitHub. I want to choose Cloud with Varjosh here. Cloud with Varjosh is my username for Docker Hub. So I will come down now. Now let's see what we are doing here. Understand that when you are using this, what happens is Jenkins credential binding injects this and this at runtime and masks them in the console output. So when you are using this variables, you will not be seeing what your passwords are in your console output, and that is what you want. Imagine if you were to type your password here, Control C, Control V. If you are doing this, my username for, let's say, Docker Hub is Varun, and then my password is, let's say, Varun, then you would see all these in your console output. We do not want that. Hence these bindings, whatever binding that we just created, bindings, this will help us redact our passwords. You will just see asterisk when you see the console output log. Even when I am running echo this password, you will not see this. So these won't be displayed. The values for this won't be displayed. But you might be thinking, then Varun, why are you using this format? This format is what is recommended by Docker. So you must be thinking why I am not using this, because I could have used the password using this format. And Varun, you have just said that the passwords are redacted, so we can use this, right? And you can, of course, you can use this, but the recommendation from Docker is whenever you are using any passwords, use this format. So you echo this and Docker login, you ask this command to take it from standard input, and this is the standard input. So I hope this is understood. Now let's move to the second part. So understand this build's first step was Docker login. Now let's see what is the second step. The second step here is image naming. I am creating two variables here. The first variable is image, and image is, we know this is the path, and you could omit docker.io because we are using Docker to run our containers, and default image path has docker.io already added. I could have started this from Cloud with Varjosh, and let's do that. And while you are practicing, you can add this. So I'm saying image, the image variable has the value Cloud with Varjosh cwvj-flask. So this is what the name of the repository is, and this is my account name. Tag, I am saying concentrate on this thing. I am not supplying the tag manually. I have variabilized it, and I am saying use the inbuilt variable called build-number for my image tag. So understand, whenever you see your image in Docker Hub, let's say with tag 9, you would know this image resulted from build number 9 in your Jenkins. So try to connect the dot, and as we progress with this course, we will see what are other ways to integrate tags, what all other methods you can use. And anyone, if you are just watching this lecture, you can get the information about built-in variables from here. So these are all the built-in variables that Jenkins provide you. So if I run build-number, you see build number, the current build number, such as 153, an example. So when we run this for the very first time, this pipeline, this Jenkins job for the very first time, it will have the build number 1. So that is image naming for you. And then the third step is this one. I'll paste it here. And what is the third step? We are saying build and push exact tag plus latest for convenience. Now understand, we are just echoing building image. Then I'm writing docker build-t. I am creating two tags. The first tag is image :tag, and this will take the values from here, and we have defined these values here. And then I am adding one more tag, and which is latest. And why you are doing this, Varun? Understand that if someone tries to pull the image without supplying any tag, then by default the latest is added. And if you do not have latest in your container registry, then that will error out. So for convenience of other developers, whenever you are creating a container image, you add the latest tag as well, so that if someone tries to pull the image without supplying any tag, then they do not face any error. They get whatever you have pushed as the latest tag. So every time you create a new version, you also create a latest tag. Now again, in some of the projects you might see that latest tag is not at all available, so that developers will have to provide the exact tag that they want to fetch. And in our previous lectures we have also discussed, in production you would see, instead of tags, in place of tags, right now we are using the build number, but it is the image digest on the basis of which the images are pulled, and that's a discussion for a different lecture. So for now, understand we are providing two tags here. Now let's see what is the fourth step. And in this step I'm doing few more things. Once the image is built, I'm also pushing it. So here is the pushing command. So I'm saying docker push this, docker push this. And why will I be able to push this? I will able to push this because I've already logged into my Docker Hub. This is extremely critical for you to understand. This push will fail if your credentials do not work. So let's come down and add point number 4. 4 is just deploying. So let's come here and I will add this and deploy on the Docker host, DOOD, echo deploying docker pull docker rm this. Now in case you have a container that is already running with this name, then this command will remove it. It is for convenience. And then in the next step I am saying docker run -d -name. This is the name of the container, and then I want to expose my container on port 5000 in the Docker host, and that will hit on container port 5000 where my application is listening. So I hope this is connecting all your dots. So if I go back, and the last step I want to add is the 5th step is this. Let's add this. I will save this, and then let's click on build now. So if I click here and I go to console output, this is showing me live what is happening. So understand, we have the git step, which is why it is performing a git checkout. And see, it's saying echo logging into Docker Hub, logging into Docker Hub, then echo. See, it did not show us the password. We wrote echo Docker Hub password, but it did not show the password here, which is the reason we used the binding plugin. Then it is saying login succeeded. Image is equal to cloud with vargeorge. This tag is 1. Why is this 1? This is 1 because this is build number 1, and we asked it to tag our images based on the build number. And if I scroll down, it is running docker build -t. It is building that image. Then if I scroll down, you see all this process when you create Docker images and then you create a container out of that. So all of these things you will see here, and see docker push. Now we are pushing. So that implies our login was successful. It is pushing, and then it says docker push this. If I scroll down, layer already exists. Scroll down, then it is finally deploying step. Deploying docker pull cloud with vargeorge this, pulling from this. And if I scroll down, docker remove this, it says error response from daemon, no such container, because container with this name was not there in my Docker installation right now. So then I'm finally running this container, and I added a sleep 2 seconds. Now it is saying hit HTTP localhost 5000 to see the application. So I can right click on that, open link in new tab, and here it is localhost 5000. Welcome to cloud with vargeorge, built with Flask, shipped by Jenkins, running in Docker. That is how cool Jenkins is. You have successfully not just built an application, you have deployed it onto Docker host. And this is just the beginning. Imagine if you want to deploy it onto Kubernetes, you just provide the credentials and the information about your Kubernetes cluster, and it will deploy onto Kubernetes. So this lays the foundation of whatever we are going to discuss. So I hope you are watching these lectures in sequence for everything to connect. So now what I will do is I want to show you a few more things. I will go here, whatever logs we have seen. So these are the logs. I would encourage you to see all these logs and compare them with the commands that we have run. So I'll go to my CLI here. I am in the workspace. I'll hit ls, and yeah, now you see there is a workspace for this created. So I will cd into cloud with this directory. I'll press ls, and you see whatever was there in my GitHub repository is here. And if I run Docker images, you will see that the image that we just created, we tagged it with different tags, tag 1 and then the latest tag. You see these here. If I go to my browser and I go to my Docker Hub, I click on refresh here, we will see cloud with varjosh hyphen Flask is here. So if I click here, you will see there are two tags which are available, latest and 1, and you see the digest is the same. The digest is same because the contents of both these tags are the same, and we discussed this in, I think, day 2 of this series. So I hope all of these things are making sense. Now what I want to do is I want to also clean up this directory once this is successful. So what I can do is I can add one more step. We discussed about cleaning up the workspace in the previous lecture, correct? So I want to do just that. So I'll click on configure, and now understand this will also, so if I append this, I want to append this cleanup step, and if I do this, this will also create a new build. So if I add this and I save this and I run this again, what it will do is it will create one more image for me, but it will also clean up my workspace, and that is what I want for now. So let's click on save and see what it is doing. Cleaning workspace, and we saw this in the past lecture as well. We are using a built-in variable that is workspace, and we are just asking the current workspace, just clean this after you are done. So I'll save this. I will just click on build now, and this will again build this image, and this time you will see the tag is 2. So let's wait for it. And this is the reason, if I go to configure again now, I added this step because we know that this container would already be there, but this command will first remove that and then redeploy the container with tag 2. So let's go here, and then let's go to the console output here, and it is deploying. It's in the final steps and it has successfully deployed. So interesting thing is, now I want to go to item, hit ls. You don't see anything because we have cleaned up our workspace. And a few important things are, if I go one step back and I hit ls, whatever credentials, I'll go one more step back. If I press ls, whatever credentials we have saved, they are saved in this file. They use both encoding and encryption, so you will not see them in plain text, but know that they are saved here. So even if you delete this Jenkins instance you recreated, you will see your credentials are still safe because they are part of Jenkins home. That is all I wanted to cover in this lecture. So that wraps up day 5. You configured DOOD, used Jenkins credentials, no secrets in the script, built a Docker image, pushed it to private registry, and deployed it on the host using pinned tag for traceability. You now have a clean, reproducible CI flow you can extend. Next, in day 6, that is project 2, we will refactor this into a pipeline, which is also known as Jenkins file. If you have any questions, feel free to ask them in the comment section and I will reply. If this helped, do consider liking, sharing and subscribing. It will mean a lot to me. Thank you very much.